This lesson is on linear equations, and the first thing that we're going to want to talk about is finding the slope between two points. Remember that slope is equal to rise divided by the run. So what I mean by that, so we have a line at this point and this point. This is the rise, which is going up. This is the run. Rise can also be going down if the line is going sloping in the other direction. Another way that we can write this is if we talk about 2 points, x1, y1, and x2, y2. I can write it as the change in y divided by the change in x. In these, it does not matter whether or not you do 1 minus 2 or 2 minus 1, as long as you are consistent on the top and the bottom. Positive slopes going up from left to right. Negative slopes go down from left to right. So it's another way that you can check yourself whether or not you did it accurately. So our first example, we have to find the slope between the points -3, 4 and 1, 5. So if we wanted to, we could just do a quick sketch. This is not to scale. Get them too close together here. This is our middle line. Our slope is often indicated with an M. So I would do change in y, so 4 minus 5, those are my y values, over, I did the 4 first, I could do the -3 first, minus 1. So 4 minus 5 is -1, -3 minus 1 is -4, and those divide to be a positive 1, 4. So our slope is 1, 4. Now we can use our slope to write our equations of our lines. We have two different forms. One is slope-intercept, which is y equals mx plus b. Most people know that one. M is the slope, b is that y-intercept, which is where a line crosses the y-axis, so that's point 0b. We also have point slope, where that x1 and that y1 represent an ordered pair on the line. We're going to write the equation between the same exact 2 points that we have for that first example. So from our first example, we know the slope is 1, 4. We're going to write it 2 different ways. So in slope intercept form, we have y equals mx plus b. So the problem becomes, well, I don't know what b is. We can find b by substituting in one of the 2 points. It does not matter which one. I'm going to substitute in the second one. Most of the time people only do the first. So we have 5 equals 1, 4 times 1. So if I subtract 1, 4, so let's rewrite my final equation is y equals 1 4 x plus b. Now you can check that by substituting in the other ordered pair. So if I plug in negative 3 for x, I get negative 3 fourths plus 19 fourths. 16 fourths, which is 4, so I get negative 3 4. Most people do like slope-intercept, or they kind of default to that one. My only concern with slope-intercept is what happens is a lot of students forget to rewrite the equation. You find the slope, you find the y-intercept, and then you stop and you don't write the final equation. So make sure you write the final equation. Point slope form. You choose one of the 2 points. So one possible answer is y minus first y equals the slope times x minus the first x and minus a negative times 3. And you're done. Your other possible answer is y minus 5 equals 1 4 times x minus 1. Now on both of those, 1 and 2, they're both equivalent equations. Both will work. It doesn't matter which one you do. If you were to distribute the 1 4 and then add those y values to the other side, you will get slope-intercept form. We're also going to be graphing equations. Just give ourselves some space here. Graphing linear equations. We have y equals 3x minus 5. So one way that you learn how to graph, it's time to do graph paper. Just because you don't normally have graph paper, although in my classroom you are welcome to pick up a piece of graph paper, or if you just search online for graph paper, sometimes they call it grid paper, you can find some that you can print out, and you can always just go to the store and buy it, or you can just make them, like I just did. So one way that you can do is you can make a table. So you can do x, pick numbers. Usually we do like negative 1, so if I plug in negative 1, I get y value of negative 8. 0, I get negative 5. 1, I get negative 2, so again those are just by substituting numbers. Another way that you could do it is identify the y-intercept, which is negative 5. 1, 2, 3, 4. And then use that slope, which is 3. So that means for every 3 it goes up, it goes over and over. So 1, 2, 3 over 1. 1, 2, 3. 1, 2, 3 over 1. And you can keep going. You'll notice here I get the same point, the 1, negative 2, as I did with the table. Either way is completely acceptable. And then draw our line. Your line should have arrows on them. Draw arrows on each side. So now we come to x equals 2. Well, that one's not quite as easy, just to make an xy table. And then when I start to look for a slope, I don't see a slope there, y-intercept, so it doesn't really fit in slope-intercept form. What this is saying is all the x values are 2. So, well, x is 2 at the points 2, 0, 2, 1, 2, 2, 2, 1 half, etc. So all the x's are 0, so what ends up happening is we get a vertical line where all the x's are too. Similar in nature, is for y is -4. That means all the y values are -4. So 1, 2, 3, y is -4, y is -4, y is -4, and I could keep going. All the y values are -4 on this horizontal line. So the last two things we want to talk about is parallel and perpendicular lines. So parallel lines have the same slope. Perpendicular lines, the slopes are negative reciprocal. So what we need to do is find the equation of a line passing through the point 3, -1 that is parallel to this line and then also perpendicular. The first thing we're going to want to do is take that 3x minus y equal to 5 and get it into slope-intercept form. But add y to both sides, and there's more than one way of doing this. Some of you might have looked at that and said, well, I can subtract 3x, that is fine. I just didn't want to divide by negative later. And then subtract 5 from both sides. So I have y equals 3x minus 5. So the slope of this line is always the number in front of the x, which is 3. So if we want to be parallel, we'll use a slope of 3. Whereas perpendicular, it says the slopes are negative reciprocals. So that means it's the opposite sign. So if this is 3, it'll become negative. And the reciprocal of 3 would be 1 over 3. Let's just talk about a couple of reciprocals before we continue on with this. This is kind of like a side note. So 2/3, its negative reciprocal would be -3/2. Or say -5/7, its negative reciprocal would be positive. Try that again. 7/5. And just one more. Let's do -1/2. Its negative reciprocal would be 2. So that's what you're going to do with your negative reciprocals. You just flip over the fraction, and if the fraction happens to be an integer, it really would have a 1 on the denominator. Okay, so let's go back to our parallel line. So we know it goes through the point 3, -1 with this slope. Let's do this one in point slope form. So y minus the y coordinate equals the slope times x minus x coordinate. So that's what is in point slope. To do, we'll do the other one, the slope-intercept. I think most of you, it's your default position, so you have a lot of experience with slope-intercept. If that's not true, do let me know. We can go over some more examples in class as well. So this one, slope is -1/3, and it goes through the point 3, -1. Point slope, y minus the y coordinate equals the slope times x minus x coordinate. Do you follow the directions to see if they want to have it in point slope or slope intercept form?